I come from this institute where this gentleman, anybody knows this person? C.V. Raman. By the way, and I have seen many students, in fact C.V. Raman was very unhappy. Did somebody told Sir C.V. Raman? Some of you? No. He used to be very unhappy if somebody used to call him Sir C.V. Raman. Because Sir is not in our culture. Our culture is Shri. Mannevar. So Sir is a kind of a British way. By the way, this is a fantastic story. I mean, see, you can always do good science only if you like to do what you want to do. And you will like your place only when you will love your country, right? If you don't, आप अपने लोगों से प्यार नहीं करोगे तो आप molecule से क्या प्यार करोगे? जिसको, by the way, has anybody seen a molecule ever? No. We measure them indirectly. But do we see ourselves? Yes. All of you are seeing yourselves. So if you are not able to like each other, I mean, in other words, you are not able to like your environment, your own people, then how would you like molecules, or for that matter do anything useful? So C.V. Raman discovered Raman effect. Then he was a faculty in my institute, in the Indian Association for the Cultivation of Science, and this is the instrument in which he first recorded a Raman spectrum. You know how much does this instrument cost? 20 rupees. Not that time, even now. I mean, he made it from, he took some वो काट लकड़ी का लेके अपने हाथ से बनाया. Even now you can make it 20 rupees. What is the so great thing about it? Because he made it for the first time. You don't need to do high-fi things for being genius. Doing small things, but doing it really well would give you Nobel Prize. That's the point. So this instrument, making it will take 50 rupees maximum. Those days also, by the way, C.V. Raman had never taken 1 rupee from the government. You know why? Because that time the government was British government. And C.V. Raman would never work under a British. So that is why he came to this institute in the Association for the Cultivation of Science, which was an all-Indian institute, in which there was no foreigner. So that is why he wanted to do research, get a Nobel Prize in India, to show that Indians are capable of doing world-class Nobel Prize. By the way, C.V. Raman discovered it in 1923-24 and he got Nobel Prize in 1930. Do you know who was the person who got 1 year after that? I mean, people, Pauli exclusion principle. And after that, people like Heisenberg. So he got Nobel Prize when the real genius of physics was evolving. It was not now. I mean, those days there was those genius, Pauli, Heisenberg, Dirac, those very, very smart people. And between that, there was this Indian, this Madrasi, and he was, of course, this Madrasi coming from all across India, and he got a Nobel Prize. An experimental Nobel Prize. He was a pure experimentalist. Okay. And he published the paper in Nature. Okay, and Nature was a journal, even now it is published from London. In fact, if somebody is interested, I will send you the article. This was a half-a-page article. ऐसे कहते हैं ना कि जो लोग बड़े लोग होते हैं वो कम बात करते हैं, कम बात में ज़्यादा बात बोल देते हैं. That is the point. So by the way, this is a nice story about Raman. So Raman got Nobel Prize. But I know this because I am a faculty from his institute. 2 years before getting Nobel Prize, from 1928, every year, the time Nobel Prize will be announced, just around October, November, he used to buy the ticket and keep it under his drawer, in the expectation that he will get Nobel Prize. Tell me, that is the kind of confidence he used to have. Okay. And he used to buy the ticket and keep it in the drawer. Because, if he gets Nobel Prize, then it will be late, because they will announce 2 weeks back, so he used to buy the ticket and keep it in his drawer. So finally when he got, he was so happy. So when he got, he realized that he didn't have a coat. So this is the coat, so he bought the coat. And then he went by those days he used to go by ship. There was no flight, those days. So he went by ship. And when he reached there, he started crying. The reason why he started crying is because the king will present the award, in Nobel Prize. So when the king started, the Swedish king started giving the prize, and there was this chair, like all the Nobel laureates were sitting here, and behind the chair, your flag will be there. So the Britain guy, the British flag, India's flag, everybody's flag. Then Raman started crying that my poor country doesn't have a flag of its own. Because India was not an independent country those days. So that is the genius of Raman. So you have to see. So I will again tell you examples where what Raman did was absolutely doing chemistry. He got a Nobel Prize in physics, but nowadays we do Raman spectra for any molecule. For example, if you say, for example, have you seen this? आप अगर diamond खरीदते हो, in fact Gujarat is very famous for diamond cutting industry. They will see this diamond, the purity of the diamond. They will give you a card, which will say purity of the diamond is this much. How do you measure the purity? No, carat is a kind of. So there is a purity of the diamond, and the purity of the diamond is measured by the peak in the Raman spectrum. In the Raman spectrum, there is this peak which is very particular about a carbon-carbon single bond. See, diamond is a kind of, it doesn't have any pi electrons, everything is sigma. So of course, if you shine light, the molecule will vibrate, it will breathe. So there will be a breathing motion, and that breathing motion gets seen in the Raman spectrum. And that intensity of the Raman spectrum is proportional to the purity of the diamond. So if some diamond guy has mixed something, you will immediately see that that peak is not coming there. In fact, that is the way the purity of diamond is. That is very interesting story. But Raman was so poor, he didn't have any diamond. So how did he do this? So what Raman did, Raman used to approach the Maharaja of Mysore. He would say, "Sir, I am a poor scientist. I know you are a very rich man. You have a lot of diamond. Can you give me one diamond? I will do the experiment and return it back to you tomorrow." So he will take the diamond, he will put it in his laser and note down its spectra. Oh, okay. Tomorrow he will reveal it. So he took diamonds of various size, shape and all those, and from that he did the calibration. So that is the way you check the purity of diamond. Right? So that is the kind of very simple things, but very original. That is what is chemistry. Okay. Next. So how old is chemistry? Chemistry is actually a very old subject. You can't have anything older than this. In fact, I will try to convince you, maybe in the next 10 minutes, in fact, chemistry is as old as history, because history is named after chemistry. I will try to convince you that. You will see in 2 minutes. History is named after chemistry. I am not joking. There is a lot of reason. Okay. So when I say chemistry is very old, that is true. Chemistry is as old as history, and chemistry is as young as this young man. He's been in a lot of movies nowadays, and all of you know what is his name. He's in big demand. Okay. So chemistry is also very young, handsome gentleman. Yes. And in fact, chemistry is also ever young. Yes. Next. Okay. So I am trying to convince you that chemistry. People say no, chemistry में history है, बहुत रट्टा मारना पड़ता है. I would argue opposite. In fact, history is named after chemistry. Why do you say so? If you go and look back your history books, first what came? Copper Age. Alright? Copper Age means, Copper Age is somewhere very close, Harappa, Mohenjo-daro. Here, nearby, now it is in Pakistan. Why is it called Copper Age? Have you ever thought? Yeah, those days people, yeah, please.
Because there was more use of copper in that.
No, in fact there was nothing else. The only metal available was copper. Why? Because those days there was no technology. What is the ore of copper, Sulfide. So iron sulfide or copper sulfide. But you need pure metallic copper. How do you get that? You need to reduce. How do you reduce? You reduce it probably with carbon. But then if you reduce it with carbon, you need a temperature which is around that of 1200 degrees centigrade. And that was the maximum temperature technology which they had. They could not go to higher technology. Since they could not go to higher technology, the whole history, the whole civilization, the way people were born, the way people lived, in fact the way people fought, right? In fact, there is this theory, in fact the Harappa Mohenjo-daro civilization got wiped out, followed by the Arya civilization came. And what was Arya civilization about? Bronze Age. And it is said, what is so special about Bronze Age? Because alloys, bronze is an alloy of copper and tin. Why? Because when you make intermetallics, when you mix two metals in the individual places of their defects, one metal will go inside another metal and make it stronger. So the tensile strength of an alloy is more than that of the native metals. Depends on the way you make it. So of course that age is called Bronze Age because the metal in which they were using was bronze. And for getting bronze, you need a temperature of about 15 degrees centigrade, 15,000 degrees centigrade. And of course people in the Copper Age didn't have a technology to reduce copper. So everything depends. And finally came the Iron Age, right? Iron Age of course is from, you convert from BC to AD. And what is the ore of iron? Oxide, right? Hematite, Fe2O3. It has some other metals also. But for that you need a temperature of 2000 degrees centigrade. Of course people in the Copper Age never had that technology. Since people didn't have the technology, those older civilizations were wiped out when the new technology came. And the new technology was based on the metal, and that metal was based on the simple chemistry of reduction of an oxide or a sulfide to its native form. Absolutely chemistry. So when we talk about Copper Age, Iron Age, Bronze Age, remember it's all about chemistry. So next time when you will meet any history graduate, you tell him, listen, your history is named after chemistry. Okay? So we gave you the name. Okay? Very nice. Of course, now what is our age? Our age is actually our polymer revolution. We are living in an age, we are actually now living in a kind of age where a lot of things are happening. And what are the things which are happening? Okay, before our age was the age of steel revolution, industrial revolution, steel, right? Bridges, roads, everything was made up of steel. And what is steel, by the way? Steel is an alloy of iron and carbon. And you know why steel is stronger than carbon? Because as you know, if you have iron, iron has a lot of defects. There are various kinds of defects, screw defects, point defects. And when you add carbon, by the way, if you take 1 kg of iron and of carbon and mix it in 1 kg of iron, it will not work. There is this particular quantity of 4%, because the number of defects in terms of volume is just 4%. So you make sure that every single defect, a carbon goes in, and carbon forms a compound called C4Fe. C4Fe, that compound, it's a non-stoichiometric compound, and it brings the things together. Lot of chemistry, you have to understand the atomic details. Okay. Of course, we are living now in a polymer revolution. Absolutely polymer revolution. In fact, has anybody seen a bag other than made up of a plastic? I mean, when I was a student, we used to have jute bags and so on. I mean, nobody buys jute bags anymore. Our life has completely changed due to polymer. Now, some of my all these newspaper guys will tell me polymer mein bahut pollution hota hai, polymer is bad. I mean, don't use plastics. All these points are very well taken. But my argument is, if there was no plastics, then I don't know what would happen to a lot of people. Of course, you have to check your balances. I mean, you should not overdo things. And of course, what is the revolution in which all of us living? It is there in all of your pockets. Silicon, right? And all your chips, all your mobile chips, everything is made up of silicon. So we are living in a world in which it is a silicon. It's an amorphous silicon which gives you the junction diodes, PN junction diodes, right? So we are living in an age, electronic age, and what is the material made up of? Silicon. What do? You take amorphous silicon, you dope with N-type materials like nitrogen, antimony, and you dope with electron deficient materials like boron, right? And then you get PN junction diode, and everything, as all the rectification. So whenever you call your friend 01998, all those numbers, it's all getting converted into those bonds which have been formed. You have to understand that. That is the detail in which it is working. Now you might say, why do I need to understand this? Well, I get a mobile, I use it. But then who discovered the mobile? Every single mobile, you are paying some money to the guy who discovered it, right? Some patent you are giving, Nokia, right? Of course, Nokia has been bought over by Microsoft, they told, right? Why would somebody buy? Which means they have the rights, they have the copyrights. So every single mobile you are buying, right? Every single pen drive you are buying. You might say, sir, one pen drive costs only 100 rupees. Doesn't matter. Out of that, 20 rupees is going to copyrights. One CD comes for 5 rupees. Doesn't matter. Out of that, 3 rupees goes to copyright. You get my point? So all this, the real ability is to make that intellectual contribution, to do it for the first time. And for that you need chemistry. You need to make devices, right? Of course, we are now living in a silicon revolution. But I would tell you that silicon revolution is at there only for next 5 to 10 years. By the time you will grow